Hi friends, in this session we will discuss about curriculum development. Curriculum development, conceptual analysis. In ancient times, learning experiences that disciples had were under the auspices of their guru within the Gurukula system. Today, most of the experiences that learners have acquired under the auspices of the school are generally considered as curriculum. Curriculum is the sole process of education. It acts as a pivot in organizing educational efforts on some manageable basis and is undoubtedly the heart of school and all that goes with it. The concept of curriculum. The term curriculum is derived from the Latin word curre, which means to run. Hence, curriculum means a course to run for a teaching goal. Usually, the term curriculum is understood as a group of subjects prescribed for study in a particular course. But curriculum is not confined to this narrow concept. It is not merely the content of instruction, but it is the sum total of the experiences the pupil receives through the manifold activities that go in the school and in the numerous informal interactions between the teacher and the pupil. Curriculum is a plan of learning consisting of two major dimensions, namely vision and structure. Vision in the curriculum is the product of a set of assumptions about people and the world at large and takes the form of some conceptualization of reality. Any curriculum always contains some value laden assumptions about the purpose of education in our society. Definitions of curriculum. Curriculum has been defined by different persons in different ways. Some of the definitions for curriculum by various experts are given below. Cater V. Good. Curriculum is the general overall plan of the content or specific materials of instruction that the school should offer the students by way of qualifying him for graduation or certification for entrance into professional or vocational field. Cunningham. Curriculum is a tool in the hands of the artist, means the teacher, to mold his material, means the pupil, according to his ideal, means the objective, in his studio, the school. The material is highly self-active and responds consciously. Secondary Education Commission defines curriculum as curriculum does not mean academic subjects traditionally taught in the school, but it includes the totality of experiences a pupil receives through manifold activities that go in the school, in the classroom, library, laboratory, workshop, playground and in numerous informal contact between teacher and the pupil. Foundations of curriculum development. Any curriculum, if it is to serve the purpose for which it is constructed, must be based on sound foundations. As any system of education is based on philosophical, sociological and psychological foundations, the curriculum also should be developed accordingly. Philosophical foundation. It is the philosophy of a society that determines the ultimate aims of its education. The social structure and economic organizations are based on philosophical foundations. Philosophy considers fundamental and profound issues such as man's place in the universe, the aims of nature, aims of society, relationship between man and society and so on. Various philosophies have different views on different issues. These differences are sure to be reflected in the respective educational systems and hence in the curricula also. Sociological foundation. The sociological foundation demands that we should bear in mind the needs, requirements, aspirations of the community for which an educational system is designed. Sociological approach considers not only the needs of the society, but also the needs of the learner. It also reflects upon the future needs of the individuals and the needs of the elders. For serving these functions, the cultural heritage of the society also should be reflected by the curriculum. Psychological foundation. The most important basis of curriculum formation is psychological considerations. In modern times, so much research has been conducted in the sphere of educational psychology that it has become an independent branch of the study. The result of these research studies have great impact on shaping of curricula. This is only natural because curriculum is the means to the learner's development and hence it should be in tune with the psychology of the learner. The curriculum development mainly concentrates on the following stages. Analysis means what educational purposes shall the school seek to attain. Design means What educational experiences can be provided that are likely to attain these purposes? Implementation. How can these educational experiences be effectively organized? Evaluation. How can we determine whether these purposes are being attained? Curriculum development is fundamentally a plan of structuring the environment to coordinate in an orderly manner the elements of time, space, materials, equipment and personnel. The basic cycle analysis, design, implementation and evaluation guides the curriculum improvement process regardless of the level of focus or operation. Curriculum and instruction. Curriculum is a plan for bringing desirable changes in student behavior. Instruction is perceived as a planned interaction between teacher and students that result in desirable learning. Curriculum and instruction are interrelated. Curriculum plans and materials are activated through instructional methods for modifying the behavior of the learner. Curriculum and education. Curriculum is intimately related with all aspects of education. Education is a developmental process geared towards the coveted goal. Curriculum is the input as well as medium that provides with the goal oriented direction to that process, while education is the result of learning. Curriculum signifies situations and experiences for learning. Curriculum is the plan for guiding goal oriented educative process. This plan considers four important components, namely objectives, the content or learning material, teaching learning strategies and activities, and the last one, evaluation. Curriculum and syllabus. Curriculum is not merely syllabus because the latter is only verbal, book oriented and theoretical, while the former is not. Syllabus is much more specific, speaking of the details of the study, the hierarchical order of presenting the content, etc. Syllabus places more stress on the specific learning materials to be internalized. On the other hand, the scope of curriculum is much broader and deeper, for it comprehends every aspect of the educator's life, seeks to satisfy all his requirements and aspires to develop every aspect of his personality. Curriculum encompasses various kinds of curricular and co-curricular activities as well as the various aspects of the social, natural and educational environment, with a reference to which the experiences are transacted. Now, we will discuss on the principles of curriculum organization. Curriculum organization is a scientific process involving basic principles on which the credibility of the curriculum results. Some of the principles are: principle of child centeredness. Curriculum should be child centered. It must be based on the present needs, requirements and circumstances of the child. The child should be brought to first hand experiences than giving wholesome instructions in the classroom. The curriculum should be planned in such a way that it promotes the interest of different age groups through variety of experiences. Principle of need. A well designed curriculum should provide suitable opportunities for fulfilling the varied needs of the learner. This implies that pupils' physical, emotional and social needs must be met. One of the important problems the curriculum developers are grappling with is the need of differentiation of curriculum to suit varying needs of people. For example, different curricula for urban and rural children. How does one tackle this problem? Principle of utility. Curriculum should be of the practical use to the people and hence should maintain vocational and technical bias. It should provide the child with sufficient opportunities for both academic and social growth so that the child can use knowledge in his day to day life. Principle of readiness. The curriculum should be based on sound principles of learning. Students learn subjects when they are taught at the most appropriate time, that they are ready to learn. Readiness depends on learner and the environment. This principle stipulates that the curriculum planner should organize the curriculum in such a way that it is possible for the teacher to teach the content at the appropriate time. Principle of social relevance. The curriculum should be relevant to the personal needs of the student as well as needs of the society. Besides treating each child as an individual, we should also view him as a member of the community to which he belongs. So, if such a recognition he receives, then his needs and desires must harmonize with the needs and desires of the society. Since the society is not static, the curriculum planners should consider this dynamic nature of the society. Principle of integration. The curriculum should integrate the child's needs and activities on one hand and the needs of the society on the other. Each country has its needs and priorities. The boundary conditions are set by political, social and educational aims as well as by the cultural milieu and economic realities. Principle of conservation. The curriculum should preserve and transmit the traditions and culture of human race. It should embrace such subjects, topics or activities by which students should cultivate a sense of respect for their traditions and culture. Care should be taken while selecting such subjects because it should be according to the mental development of the people. Principle of activity centeredness. The curriculum should be such a way that it should provide variety of activities for the physical and mental development of the people. The activities should be planned so that it should foster the need and ability of the people. This principle is according to the maxim learning by doing of the pragmatic philosophy. Principle of balance. The curriculum should maintain a realistic balance between objectives and content, objectives and abilities, objectives and learning experience. Selection of content should be based upon the up-to-dateness, accuracy and adequacy. Similarly, a child's abilities must be matched with the objectives to be attained. Suitable learning experiences must be designed to attain these objectives. Principle of comprehensiveness. The curriculum must be comprehensive enough to conform to the needs of the individuals or communities. It must be broad based to include a wide variety of subjects suited to the needs of various types of peoples and the society with all its diversities. Comprehensiveness has to be reflected also in its potential to cater to the comprehensive or total development of an individual. Principle of creativity. Curriculum should foster the creativity of the people. By nature, man is creative. Therefore, education should be so molded as to enable one to develop one's creativity. The curriculum should consist such items that would enable children to exercise their creative powers so that creativity is fostered, which in turn will enable them to modify their environment according to the needs of time. Next, we will move on to approaches to curriculum organization. The various approaches to curriculum organization are topical approach, logical and psychological approach, subject centered approach, activity approach, integrated approach. Now, we will discuss topical approach. In topical approach, the topics from a particular subject are selected and arranged in order of relevance. A topic is a comprehensive collection of related learning materials pertaining to a specific area of the subject. A topic may be so complex and might include a large number of items of varied difficulty. To pass on to another topic, it is essential to master previous one. Topic can be divided into large number of units and a unit may be a part of the same topic. Properly linked units act as the essence of this approach. This type of approach can lead to a lopsided syllabus with a bias heavily for or against some subjects. Also, it may be rather difficult to retain balance, sequence and coherence in the curriculum because of individual bias. Logical and psychological approach. The arrangement of subject matter is based on the principles of psychology. Here, criteria for including an item in the curriculum will be the psychological needs, requirements, abilities and skills according to the mental development of the people. The principles of learning such as readiness, transfer of training, reinforcement play an important role in this approach. In the logical approach, stress is given to the logical sequencing of the subject concerned. Contents of every subject have been developed in tune with such a logical sequence. If a curriculum is prepared based on the psychological principles, then logical continuity should be maintained in transaction. Subject centered approach. In the system of organization, separate subjects are dealt without any integration. For example, science is treated in separate compartments such as physics, chemistry, zoology, botany, etc. Topics from all the compartmental subjects are treated without any attempt at correlating and integrating the learning experiences. This system is considered to be the best pattern of curriculum organization for producing scholars with high grade specialists in earlier years. This pattern is criticized on the ground that it is compartmentalized and fragmentary, fails to develop effective habits of thinking, and ignores the natural interest and abilities of children. Activity centered approach. Activity centered approach is also called as the experience curriculum or project curriculum. Here the stress is given to the process aspect of science. Theories of great philosophers like Rousseau, Dewey, Plato are the base for this. They stresses the importance of developing 4 impulses in children, like social impulse means sharing experience and ideas, constructive impulse means play, rhythmic movement and working with raw materials, impulse to investigate and experiment means to discover things, and artistic impulse means the refined expression of communicative and constructive ideas. Consequently, the curriculum gives importance to activities that help the development of these impulses. Integrated approach. The integrated approach aspires to help pupils to obtain a coherent view of science by establishing numerous links between the various branches of science. Science is dealt with compartmental units of physics, chemistry and biology as often without any attempt to establish link between these different branches. A good curriculum should be suitable for the environmental needs of the learner as well as the society. It is always beneficial to perceive science in an integrated way than taking into different subjects. The knowledge in one of the subjects of science proves an additional benefit in acquiring the knowledge in other subjects. Organizing materials within the course. Different patterns of curriculum development relate to the ways in which science courses are organized. There is another aspect for curriculum organization, that is organizing the selected materials within the science course. There are several forms of such organization. They are concentric method, topic method, historical approach, nature study, nature rampling, type study, etc. Concentric method. The whole science course is spread over a number of years. The same topic is treated at each stage or year through successive stages or years in according to the mental development of the people, and the circle of knowledge goes on widening. In the beginning of the course, the whole picture of the topic is given to pupils in a simplified way. In the next year, more and more details of its parts are added according to their mental development. For example, in the topic water, an outline consisting of sources of water, storage, distribution, uses, etc. can be included in the first year. Purification of water, techniques like decantation, filtration, distillation, chlorination, composition of water, kinds of water, etc. can be included in the second year. Other details such as hardness of water, causes of hardness, removal of hardness, etc. can be included in the third year. In this approach, while dealing a subject, very little is taught at first. The scope is extended in the next stage. Thus, keeping subject as the center or the core, ever widening concentric circles of experience are provided in which previous knowledge is repeated and consolidated. This method of arranging the course is based on the maxims of teaching from whole to parts and from simple to complex. Topic method. The whole science course is divided into number of related topics. The subjects like physics, chemistry, biology are not treated as such, but in a correlated and integrated manner. Each topic is treated exhaustively in a particular grade. Here, topics selected are life centered, environment centered or life and environment centered, so that the courses may be closely related to the life of the people. This method of curriculum organization is advantageous as it brings the different branches of science into closer relationship and the knowledge imparted becomes well integrated and correlated. People get an opportunity to understand their environment, thereby make the subject more real and interesting. The main drawback is that people does not get sound knowledge of the subject as it is dealt in a general way. Moreover, textbook written on this line and teachers well versed in all the branches of science are not easily available. Historical method. Science has a history of its own and every invention or discovery has its historical background. The historical approach emphasizes the organizing of the science course in accordance with the evolution of science. One of the charges levelled against school science is that it deals only with objective reality and that it is devoid of any human element, and as such it is of little inspirational value. Science is a grand expression of human spirit and it is essential that this aspect should be felt by every people. The romance of science will be felt only if it is treated biographically. So, emphasis must be realization of scientific life rather than the mastery of the principles and method. So, pupils are led into the spirit of intellectual life of great men of science. Nature study. Nature study refers to the intelligent intercourse with nature. In this system, an exhaustive study of nature is aimed at. It aims at giving training to pupils to take an intelligent interest in our surroundings, to observe natural phenomena, to study common objects and to draw logical conclusions from the facts observed in our daily experiences. Nature study is the direct study of nature in all its branches. Here we can include plants, animals, natural phenomena such as weather, sun, moon, day and night, eclipses, etc. Nature study is advantageous as it lays foundation for advanced studies because all natural sciences are specialized form of nature study. It develops power of observation and reasoning and it establishes good relationship between child and its environment. The main drawback for this method is that this does not give sound and systematic knowledge of the subject. There are many topics in science which need exhaustive theoretical analysis. Hence, this system is suitable for primary classes only. Nature rambling. In this system of organizing the science course, the main criterion is the experience of the child. The child is considered as a rambler in its environment. The materials the child is likely to meet with, the scientific situations it is likely to face, etc. are chosen and are arranged in the science. Accordingly, science course of the first year may contain an elementary study of plants, trees, sun, moon, birds, stars, etc. The second year science course may consist of rocks, different kinds of rocks, kinds of water, purification of water, solar system, seasons, insects, etc. The science course of the third year may consist of sand, minerals, atmosphere, soil and different kinds of soil. Type study. In this method, the material to be taught is classified into types. The type is that which exemplifies the characteristics of a group. Here, an event or a thing is classified as an example of a class. For example, a particular plant represents the family of plants, a single element represents the group of elements, a single machine represents a class of machines, etc. In the type study, different areas are arranged according to the increasing order of complexity in the curriculum. Type study is advantageous as it helps the pupils to make their own generalizations from types. The method is based on sound psychological principles and training in scientific method and develops power of observation. The limitation of this method is that all the content to be taught cannot be classified into types. General science and disciplinary approach. General science is a course of scientific study based on the common experience of children. It tries to explain the law of nature without dividing the work into biology, chemistry and physics, so on. Normally, it consists of an elementary study of fundamental facts and principles of various sciences organized with a reference to the immediate environment of the people. The general science scheme was intended to popularize science instruction by presenting a more simple, attractive and interesting study of scientific facts and principles in relation to the real things of life. In the disciplinary approach, science is treated as a separate disciplines like physics, chemistry, botany, zoology, etc. The content is treated exhaustively and is made to cover wider areas. The advocates of this scheme claim that this system provides the learners a sound knowledge of fundamentals of various sciences and is more practicable than general science approach. Next, we discuss the correlations in science. One of the aims of education is to achieve unification of knowledge that exists as a separate and isolated one. Science cannot be taught in isolation because science represents the true life of man. Correlation means the relationship between different subjects on the curriculum. The development of the mind can be achieved when the person has got the ability to solve difficulties or practical problems. To solve a practical difficulty, combined knowledge of physics and other branches of knowledge is necessary. The problems in their daily life situations cannot be dealt with isolated knowledge of any of the subjects. Physical science must be taught in correlation in the schools to show that people should not feel various school subjects are isolated and not dependent, but they have to feel that they are mutually dependent and knowledge in one of the subjects contributes to knowledge to others. Incidental correlation. It is a natural correlation which the teacher acquires by coordinating a topic with allied materials from other subjects. This requires an exhaustive treatment of the subject, bringing about points of similarities with other subjects. The success of the incidental correlation depends on the wide knowledge and reading of the science teacher. Examples: a chemistry teacher, while teaching about oxygen, talks about hemoglobin, the oxygen carrier in blood. A biology teacher, while teaching about eye, correlates it with the camera and the formation of image in a convex lens. A biology teacher, while teaching digestive system, correlates it with the chemistry by pointing out that chemistry of the digestive juices and their effects on food. A chemistry teacher, while teaching about the structure of atom, correlates with history by telling about Kanada Muni and the progress of science in ancient India. Systematic correlation. Systematic correlation with other subjects is achieved by careful organization of the curriculum in different subjects, avoiding unnecessary duplication of this subject matter and at the same time developing related topics from different subjects. The syllabus in science must be so arranged or organized with those of other subjects that when the knowledge of a scientific principle is needed in understanding a topic in some other subject. It should not be necessary for the teacher to break the continuity of his subject and teach those scientific principles. Here, the science teacher should make use of the pupil's knowledge gained in the other subjects in the continuous development of his own subject. Systematic correlation can be effective only when the teachers of different subjects cooperate and coordinate their work. Correlation of physical science with other subjects. All the branches of science are interdependent upon each other, and there are number of facts and principles which are common to various science subjects. As a result, interdisciplinary subjects like biochemistry, biophysics, electrochemistry, geophysics have emerged and got prominence in the curriculum. We cannot classify and deal a subject separately in science without correlating it with any of the allied subject. So, correlation within the subjects is very important. In the same way, science has its correlation with social sciences, languages, music, craft and many other subjects outside the discipline of science. So, science has its correlation with all the subjects in one way or other. Correlation of science with other subjects is discussed in detail. Correlation with science and mathematics. Mathematics is probably the sole language of science, and therefore, a real understanding of science is impossible without adequate knowledge of mathematics. Most of the laws relating to physical quantities are conveniently expressed in the form of mathematical equations. Several physical quantities such as density, specific heat are not measured directly, but calculated mathematically from other measured quantities. Solution of problems in physical science is largely a question of mathematical calculation. The study of several phenomena of light involves the use of geometrical concepts and proofs. Simple ideas of statistics is essential before dealing with genetics. Experimental data obtained in a lesson of specific heat or simple properties of lenses provides real problems in quadratic equations. Kinetic theory of gases needs the knowledge of coordinate geometry. Next, correlation with science and biology. The study of natural sciences such as zoology, botany and physiology is very much related to physics and chemistry to explain some common phenomena. For example, respiration in plants, photosynthesis are explained by chemistry. The absorption and evaporation of water, assimilation of food taken from the soil and atmosphere are explained by physics and chemistry. Movements of joints and actions of the various parts of human body are explained by physics in working of levers. Nature and value of different food materials required by man is explained by chemistry. Agriculture, use of improved implements, farm factors, method of irrigation, modern ways of mechanical farming and harvesting require a knowledge of physical science. Correlation with science and language. Science students are weak in their expression, so it is very essential that science students should be able to express their thoughts in clear, concise, correct and attractive language. Science and language teachers have equal responsibilities in developing clear and accurate expression. After a field trip or visit to a place of scientific interest, people should be asked to write essays on reports on their experience. Passages from original and historical scientific works may be given for translation. Science books on natural history and biography are valuable contributions to literature and provide excellent reading material. Correlation with science and history. Even the study of history can be to a certain extent influenced by scientific approach. It is useful to mention the events in the world history which coincide with important scientific discoveries. The study of history approached in inductive and deductive methods makes us understand the interaction of events and the influence of their results on human civilization. For example, Archimedes, the king of Cyrus, found a solution to a problem when the king asked him to examine the purity of his crown. Archimedes got the royal patronage in his search for scientific truth. Similarly, Aristotle, Newton and many other scientists received royal patronage. On the other hand, Galileo had to face quite the opposite situation. Germany gained scientific leadership in the early decades of this century, and her monopoly of the manufacture of many scientific instruments paved the way for the World War I. Correlation with science and history is very prominent in topics like story of moon, story of earth, story of man and story of planets. A chemistry teacher, while teaching about iron and steel, correlates incidentally with history by telling about the famous Delhi pillar and the metallurgical skill of the people of Ayurvedic period. Correlation with science and geography. The study of geography, especially physical geography, is based on scientific principles. The fact of climates and seasons depends on the principles in physics. Some of the areas in geography where correlations with science can be seen are as follows. Instruments like barometer, seismograph, rain gauge, sundial, magnetic needle used by geographers are common to science also. The study of seabed, sea erosion, fisheries and transport can be correlated easily with science. Lessons on tides, prevailing winds, snow and ice, skin of animals, minerals and ores are nothing but scientific. Principle of evaporation, condensation, convection, crystallizations have their practical applications in geography. Rotation of plants, their influence on climate, change of seasons, flow of ocean current, structure of earth strata, action of volcanoes, earthquakes are best understood when geography is studied with the aid of physics and chemistry. Correlation of science with earth science or geology. Geology or earth science, as the name implies, has got lot of correlations with science. The study of internal structure of earth and its applications mainly deals with physical science. Some of the common areas under this section are different types of rocks and the minerals present in it, weathering, metallurgy, meteorology, scientific study of the exact measurement of weather, water and petroleum analysis, ores of some common elements and their presence in the earth, their extraction, etc. Correlation with science and fine arts. The knowledge of different notes, typical vibrating system in strings and air columns, musical scales, etc. are essential for the learning of music. On the other hand, gramophones, tape recorders, films, etc. which involve music can make science lessons interesting and real by appealing to the emotions. The principles of resonance, reverberation, etc. is also plays important role in both science and music. Drawing is of immense importance in the study of all the branches of science, especially biology. The preparation of charts and pictures requires some skill in painting. In craft work also, when we prepare some typical things is based on the scales of measurement and laws of symmetry based on science. For example, woodwork, metalwork, cardboard modeling, clay work, etc. can be successfully made use of in the improvisation and construction of science apparatus. Polishing articles of wood and metal, soldering can be encouraged among people. Next, correlation of science with the life and environment. Man lives in a scientific society. Many natural phenomena that we see in our daily life can be explained with the help of simple scientific principles. Every phenomenon and or the inconveniences faced by man in his life and environment can be solved by science. There are no problems exist in this world that cannot be reasoned with the help of science. So, science and life are correlated in such a way that they cannot be separated. So, science teachers should relate the classroom teaching with the social and physical environments by quoting examples from daily life of the child. Advantages of correlation. Education is only means to an end. All the subjects are taught to fit children into life and help them understand and appreciate it. Hence, it is not the isolated knowledge of different subjects, but the synthesized form that would be really useful to them. By correlation, the relation between different subjects is better brought about than when the subjects are separately studied. Correlations make use of the principle of apperception in the assimilation of new knowledge, and hence it promotes understanding, memory and interest. By the use of correlation, people is able to organize the different pieces of knowledge into a well ordered system, and it is the time to summarize the session. Curriculum is the soul of the process of education. It acts as a pivot in organizing educational effort on some manageable basis and is undoubtedly the heart of the school and all that goes with it. It is futile to talk how and when to teach without deciding what to teach. This module gives a conceptual analysis of curriculum in science, principles of curriculum construction, approaches to curriculum organization, organizing materials within the curriculum, etc. The module also discusses another important topic, that is correlation in science, and gives a detailed description of how science is correlated with different disciplines with suitable examples. Before we attend the next session, please try to answer these questions. First one, what are the different approaches to science curriculum construction? What approach is practical in the Indian educational system? Second, science should be made as a compulsory subject up to a higher secondary stage. Comment on the above with the relevant practices in the present curriculum. Third, what do you mean by core curriculum and hidden curriculum? Fourth one, distinguish between incidental correlation and systematic correlation. Books for reference: Modern Trends in Science Education by Joseph T.T., published from Kottayam. Science Education, Theoretical Basis of Teaching and Pedagogical Analysis by Matthew T.K. and Molecule T.M., Rainbow Book Publishers, Trivandrum. Innovative Science Teaching for Physical Science Teachers by Radha Mohan, Prentice Hall of India, New Delhi. Modern Science Teaching by Sharma R.C., Dhanpat and Sons, New Delhi. Hope you have enjoyed the session. See you next time. Till then, goodbye.